the question we need to answer, well, in part, is what is a function? And then we also have to be able to recognize if something is a function or not based on the definition. So here's a definition that I found for a function. And it says a function is a relation between a set of inputs, which we generally think of as x values, and a set of outputs, which are normally y values, with the property that each input is related to exactly one output. And that's the special part about a function. Each input is related to exactly one output. When you have a relation, which we've been talking about, you could have one input that has multiple outputs, but if it's a function, it has only one. So this is a function machine at the bottom. And the way it works, the way you can think of a function is like a machine where you put something into it, here, it does this thing, and you get something out. And it only produces one thing, or one thing for each thing that you put in. So for example, we could do something like put a 2 in there, and it spits out a 4. That could be a particular function. What did it do when it was in there?
It doubled.
Maybe. That's one possibility, right? Maybe it doubled. So you put a 2 in, it doubled, it spit out a 4. Or maybe we put the 2 in and it squared it, and it put out a 4. We don't really know, right? Yeah. Yep, so that's another possibility. Maybe you put in a 2 and it added 2 and it came out. I'm going to give you another example to see if we can figure out which of those things or maybe something else it actually did. We're going to put in a 3 and it's going to put out an 8. Did it double?
No.
No. Did it square?
No.
What is happening inside this machine? Did it add 2?
No.
No. Uh-oh. What did it do? Want to see another one? If we put in a 4, it spits out a 12. This particular function machine is taking an input, multiplying it by 4, and then subtracting 4, and the output is the result when you do that. We could think of this as, well, it's 4x minus 4, right? 4x minus 4. It's taking the x value, multiplying it by 4, and subtracting 4. So that's what this function machine is doing. But every function is doing something different. But if you think about this, 4x minus 4, if you put in a particular x value, there's only one possible y value that could come out of it, right? When you do that. And that's kind of the idea of a function. What we need to be able to do today is look at some relations and decide, are they functions or not? And if you remember, we talked about relations and we said we could write a relation as a sentence, as a table of values, as a set of ordered pairs, as an arrow diagram, as a graph. There's a whole bunch of different ways to represent relations. When we look at a relation, though, we need to be able to decide is it a function or not. So if we look at this first one, the input here is 1, the output is 6. When the input is 2, the output is 3. When the input is 4, the output is 3. When the input is 5, the output is 7. And we need to decide, is that a function? So, for every input, is there only one output?
No.
No? Which ordered pairs are you looking at that... which input are you looking at that has more than one output?
2, 3, 4, 3. Same output.
What's the input?
Oh.
The input here is 2, right? The output is 3. Is there any other input, any other output for 2? No. So is this a function? Yes. Are the following functions? Yes, this one is. Yes, there are this. It does have the same output for two different inputs, but that's okay. It just can't have the same two different outputs for one input, which this one, number 2, actually has. Do you see it?
1 and 1.
Yeah, 1 and 1. When you input a 1, it outputs a 6, but the next time you input a 1, it outputs a 3. That's not a function. Here are some relations as arrow diagrams with the input and the output. One of these is a function and one is not. Which one is a function? I got 2 different answers, the second one and the first one. So let's think about that definition again. Every input can only have one output. So if you look at the first one, 2, how many outputs does that have?
Oh.
Just one, has 4, right?
Yeah.
3, how many outputs does that have?
1.
1, it's 8. 4, how many outputs does that have?
1.
1, it's also 8. 5 has 1, it's 5. So is this a function?
Yes.
Yes,
Great.
because every input has only one output. So then if we look at the second one, 4, how many outputs does 4 have?
1.
Just 1, it's 7. What about 5?
2.
Has 2 outputs. 2 and 9, what does that tell you?
It's not a function.
It's not a function. Because that one input of 5 has 2 different outputs. And you can't have that for it to be a function. A relation can have that. This is still a relation. But it's not a function. A function is like a subset of relations. Some relations are functions, but not all. And these ones are as a graph. So we're looking at the x values. This first one's really hard to see. I'm going to just try to fix that a little bit for you. Oh, that's too big. That won't work. Try to make a smaller dot. Oops, that's too high. I can't really fix this. All right, let's look at this one, first one, and we're deciding, is it a function or not? So you look at the x value and decide, does it have more than one y value that goes with it? So looking at this one, we have an x value of -8, which has a y value of -2, an x value of -7, which has a y value of -1, and so on. All of these x values have only one y value, which means, yes, this is a function. There's an easy way to tell, though, when it's on a graph, and it's something called the vertical line test. And what you do is you take a vertical line, let me just make a vertical line, like that. Take a vertical line and place it on the graph. So if I place this on my graph, the graph should only touch the vertical line once at a time. Anywhere that I go from the left to the right. So there it's touching 1 point, 1 point, 1 point, and so on. If I put it on this graph, it's only my graph, which is that diagonal line, is only touching in that one spot. As I move to the right, it's still only touching in one spot. The spot changes, but it's only touching once at a time, which tells us that yes, this is a function. But if we go to the next one and we put that vertical line on there, then you can see that there are times when the graph is touching that vertical line twice at the same time. That tells you that it's not a function. So the vertical line test is a quick way to tell when you're looking at a graph whether or not it's a function. This one is not. If we look at the actual value, like for example, this value of 4, that's the input. It outputs both about a 3.2 and a -1.1. Those are 2 different y values for the same x value, and that's what makes it not a function. The last one, is it a function or not? Yes. There's no point where the graph is gonna touch this vertical line more than once at a time. So that last one is a function.